With two peculiar moons and a rusty red hue, Mars is the fourth planet from the Sun. In our solar system, the red planet is a chilly, arid planet. Despite having a very little atmosphere, the dusty, dead, as far as we can tell, planet is anything from uninteresting. Temperatures can drop to the point where atmospheric carbon dioxide condenses straight into snow or frost. Martian dust storms can become so massive that can cover the entire planet. And Marsquakes, which are like earthquakes on Mars, frequently shake things up. According to NASA science, it is therefore not surprising that this small red rock is still a source of fascination for scientists and is among the solar system's most examined bodies. The bright rust color Mars is known for is due to iron-rich minerals in its regolith, the loose dust and rock covering its surface. Earth's soil is a kind of regolith too, albeit one loaded with organic content. According to NASA, the iron minerals oxidize, or rust, causing the soil to look red. We've learned a lot about Mars from the past 30 years of lander, rover, and orbiter missions. We have confirmed the existence of past water on the Martian surface, that Mars was once a habitable planet, and that it once had a thicker atmosphere than it does today. Liquid water probably cannot survive on the Martian surface for any significant amount of time due to the planet's thin, frigid atmosphere. Some scientists contend that the hydrogen observed from orbit in this area may instead suggest briny salts, despite the fact that features known as recurrent slope lineae may have spurts of brackish water flowing on their surface. This indicates that even though the desert planet's diameter is only half that of Earth, its dry land area is equal. The longest, deepest valley in the solar system and the highest mountain are both found on the red planet. Olympus Mons is approximately 3 times as tall as Mount Everest, standing at a height of 17 miles, 27 kilometers. Although the Vave Mariner's system of valleys, named for the Mariner 9 mission that found it in 1971, stretches as deep as 6 miles and runs around 2,500 miles, 4,000 kilometers east-west. It is nearly the width of Australia and about 1/5 of the way around Mars. According to scientists, the Valles Marineris was mostly created by the crust rifting as it extended. The system contains canyons that are up to 60 miles, 100 kilometers, wide. In the middle of the Valle Marineris, the canyons unite in an area up to 370 miles, 600 kilometers, across. The stratified sediments inside some canyons and the large channels that emerge from their ends imply that the canyons may have originally been filled with liquid. The Perseverance Rover is equipped with a large suite of cameras, 23 to be exact, which collectively enable a wide range of scientific investigations and engineering activities. Since the rover's touchdown in Jezero crater, these cameras have served as our eyes on the ground. In less than a year, the rover has already returned thousands of stunning images of local surface features, which have provided our first in situ look at rocks on the crater floor and within the crater's well-preserved delta. Images obtained from rover cameras are critical for interpreting the crater's geologic history and identifying potential biosignatures in the Jezero crater rock record, a major focus of the mission. NASA's Perseverance Rover has now been exploring Mars for a full year, and it has captured some amazing photos during that stretch. The car-sized Perseverance Rover touched down inside the red planet's 28-mile-wide, 45 kilometers, Jezero crater on February 18, 2021. The robot has barely moved from its landing spot, but it's sending back a steady stream of visual data that's freely available for anyone to play with. Cameras on the rover and the descent module that carried it through the Martian atmosphere documented the last few minutes of the long journey from Earth in a remarkable and spectacular way. With the dramatic landing out of the way, the far more chill but no less intriguing task of exploring the surface begins. Irish filmmaker Sean Doran has taken some of the first images taken by Perseverance from within Jezero crater and processed them to create This is Mars, a short film that's one of the most captivating. The rover is searching for signs of past Mars life in Jezero, which hosted a big lake and a river delta in the ancient past. It's also collecting and caching dozens of samples for future return to Earth. Perseverance is not alone on Jezero's floor. A 4-pound, 1.8 kilograms helicopter named Ingenuity landed with the rover, tasked with showing that aerial exploration is possible on Mars, despite the planet's thin atmosphere. Ingenuity aced its 5-flight prime mission and is now serving as a scout for Perseverance, with a total of 19 Martian sorties under its belt to date. Here are some of the most memorable photos by and of the robotic duo over the past 12 months. This is just the tiniest sampling, for there are literally thousands to choose from, more than 200,000 in fact. Yet these cameras are used to image more than just rocks. Every week, the rover team also acquires a large number of images of the sky and atmosphere around the rover, which allow researchers to study environmental dynamics and weather patterns. The rover's navcam is commonly used to search for clouds in the sky and evidence of dust lifting on the surface, such as dust-filled vortices known as dust devils and other wind-driven dust events. Images captured from the Mars Environmental Dynamics Analyzer's SkyCam are frequently used to study atmospheric opacity TAU, which fluctuates depending on the amount of dust in the atmosphere. Typically, between 2 to 4 SkyCam images are acquired each sol, deliberately spread across different local times in order to assess diurnal changes in dust loading. Mastcam Z images are also occasionally used to supplement SkyCam TAU observations. On August 6, 2012, NASA's Curiosity Rover made history by descending onto the Martian surface in Gale Crater. This groundbreaking landing utilized the ambitious Sky Crane system, an innovative design that gently lowered the rover to the ground using cables after decelerating its fall with retro rockets. This method allowed for a precise landing in Gale Crater, a 154-kilometer-wide basin rich in geological diversity. The site was specifically chosen because of the central Mount Sharp, a layered mountain that potentially holds billions of years of Martian history in its sedimentary rock layers. Curiosity's primary mission was to answer one fundamental question: had Mars ever harbored environments that could support life? To accomplish this, the rover was equipped with a sophisticated suite of instruments, each serving a unique purpose. The ChemCam uses laser technology to vaporize small portions of rock and analyze their chemical composition from a distance of up to 7 meters. The Mastcam, with its 2 camera systems, delivers detailed high-resolution images and stunning color panoramas, aiding in the selection of prime sites for further study. Another critical tool, the sample analysis at Mars SAM Suite, consists of 3 instruments working together to analyze gases, isotopes, and organic compounds in rock and atmospheric samples. Curiosity has made massive discoveries during its mission. It confirmed that Gale Crater once housed a lake system, supported by layers of mudstone containing clay minerals. These clays form in the presence of water, suggesting the crater had standing water for millions of years. The rover also detected fluctuations in methane levels in Mars' atmosphere, which, intriguingly, could have biological or geological origins. The presence of organic molecules found within rock samples hinted that Mars' ancient environment might have been conducive to life. These findings laid the groundwork for exploring deeper questions about Mars' habitability. But there was more to come. Building on Curiosity's trailblazing success, the Perseverance Rover embarked on a more daring mission, landing in Jezero Crater on February 18, 2021. Unlike Gale Crater, Jezero spans 49 kilometers and harbors a unique combination of features: an ancient river delta and a long-dried lake bed, rich in carbonates and clays. These materials are considered ideal for preserving biosignatures, making the site a prime candidate in the search for evidence of past microbial life on Mars. Perseverance's mission extends beyond mere exploration. Its objectives include the search for ancient life, the collection of Martian rock and soil samples for a future Earth return mission, and the testing of cutting-edge technologies to advance human exploration. Equipped with a sophisticated suite of instruments, Perseverance excels at conducting detailed investigations. Sherlock, mounted on its robotic arm, identifies organic molecules and minerals that may signify habitable environments, while Pixel produces high-resolution chemical maps of Martian rocks. Meanwhile, the Mastcam Z camera system enables researchers to closely analyze distant targets with precise zoom capabilities. A groundbreaking addition to Perseverance's toolkit is the Ingenuity helicopter, the first device to achieve powered flight on another planet. On April 19, 2021, Ingenuity completed its inaugural flight, paving the way for aerial exploration. It continues to play a critical role in supporting Perseverance, scouting potential sites of interest, and aiding navigation. Another game-changing innovation on board is MOXIE, which has successfully generated oxygen from Mars' carbon dioxide-dominant atmosphere, a vital step for future manned missions. Since its arrival, Perseverance has already achieved remarkable feats. It has collected multiple rock core samples, particularly from sediment-rich sites in the Delta region, likely deposited by flowing water billions of years ago. These samples could hold critical clues to Mars' ancient habitability and the potential for past life. These samples are carefully sealed, ready for a potential retrieval mission that will bring them back to Earth for detailed analysis. Both Curiosity and Perseverance exemplify NASA's leap in autonomous navigation and mobility, allowing these rovers to traverse the unforgiving Martian surface with minimal guidance. Perseverance features the AutoNav system, a vast improvement over Curiosity's navigation. AutoNav processes terrain data in real time, enabling the rover to identify hazards and choose safer paths. This efficiency has dramatically increased the distances Perseverance can travel during its operations. Perseverance's ability to capture and transmit footage in 4K resolution also represents a technological leap. The visuals reveal Martian landscapes with an unparalleled level of detail, allowing scientists and the public alike to observe sand ripples, rock textures, and even the thin haze of the planet's dusty atmosphere. These images aren't just for show. They provide critical data to help geologists and astrobiologists pinpoint specific features worthy of deeper investigation. Curiosity paved the way for much of this success, offering vital lessons on everything from system durability to optimizing science objectives. For example, Curiosity's extended mission revealed that it could endure Martian winters and significant dust storms, which informed the design of Perseverance's reinforced hardware and energy systems. Together, Curiosity and Perseverance are achieving what was once only dreamed of, turning the distant red planet from an enigma into a site of groundbreaking discoveries. Through meticulous engineering, innovative technologies, and their sheer resilience, these rovers are rewriting what we know about Mars. They have bridged the gap between hypothesis and evidence, advancing our understanding of a planet that might once have mirrored early Earth. Mars' surface offers a rich tapestry of geological features, each with clues to the planet's dynamic past. Gale Crater, Curiosity's exploration site, showcases an intriguing array of sedimentary rock layers within its central structure, Mount Sharp. These strata represent billions of years of Martian history, with each layer preserving details about the environmental conditions at the time of its formation. Scientists have identified signs of water-altered minerals, particularly clays and sulfates, which point to prolonged interactions with liquid water. Mount Sharp's towering slopes act like a time machine, providing an invaluable record of Mars' ancient wet periods transitioning into aridity. In comparison, Perseverance's exploration of Jezero Crater centers around a river delta that once emptied into a long-gone lake. The delta's fan-shaped deposits of sediment are relics of flowing water that carried and deposited material over eons. These sediments include carbonates, materials known to preserve microscopic fossils on Earth. Detailed images from Perseverance reveal winding riverbeds and layered deposits, tangible signs that water not only existed, but was stable for extended periods. Beyond these craters, Mars displays sweeping sand dunes, towering impact craters, and distinctive rock formations like the famed blueberries, discovered by the Opportunity Rover, tiny spherules formed by mineral-rich water. Wind erosion continues to sculpt the planet's landscape, creating rippling patterns of fine dust that evoke a dynamic system still active beneath Mars's quiet appearance. For decades, scientists have sought answers to the tantalizing question: did Mars ever harbor life? While no direct evidence has been found, intriguing signs continue to emerge. One of the most debated discoveries involves fossil-like structures embedded in ancient Martian rocks. Past rovers have captured detailed images of peculiar formations resembling microbial colonies, hinting at life's potential existence in Mars' wetter past. Further strengthening this possibility is the detection of organic molecules, carbon-based compounds fundamental to life. Curiosity's SAM instrument revealed complex organic chemicals preserved in 3 billion-year-old mudstone, evidence that prebiotic chemistry once occurred. Perseverance has taken this investigation further, using its Sherlock instrument to hunt for biosignatures, microscopic features within rocks that might signify past microbial activity. Water has always been central to the search for life on Mars. Ancient hydrated minerals and water-formed clays, found in abundance at Gale and Jezero craters, proved that liquid water was present for millions of years in the planet's early history. Gale crater's sedimentary layers suggest a long-standing lake system, while Jezero's delta formations indicate a similar water-rich environment, both of which could have supported microbial life. The Ingenuity helicopter represents a groundbreaking leap in interplanetary technology. Designed as an experimental demonstration, this small, autonomous rotorcraft was built to operate in Mars' extremely thin atmosphere, which has just 1% of Earth's density. Its success marks the first ever powered flight on another planet. Key engineering breakthroughs were necessary to make this possible. Ingenuity is compact, with a height of 0.49 meters and a mass of just 1.8 kilograms. Its twin counter-rotating blades span 1.2 meters and spin at roughly 2,400 RPM, much faster than typical helicopters on Earth. This speed compensates for Mars' sparse air, providing the lift needed to remain aloft. The helicopter is equipped with solar panels for charging, a high-resolution downward-facing camera, and autonomous navigation software, enabling it to fly without real-time input from Earth. Ingenuity's flight altitude ranges from 3 to 12 meters, with horizontal flights extending up to 700 meters. Its onboard technology, while minimalist, delivers critical data that paves the way for future aerial explorers. The Mars rovers have not only revolutionized science, but also transformed public perception of space exploration. Through high-resolution images and videos, they bring an alien world to life, allowing humanity to experience Mars without leaving Earth. The 4K footage captured by Perseverance elevates this connection, showing the red planet's dramatic landscapes in unparalleled detail. The impact of Mars exploration reaches classrooms across the globe, inspiring an interest in STEM. Programs like NASA's Perseverance Student Challenge have directly involved students in problem-solving exercises modeled after real mission scenarios. Teachers use images and data collected by the rovers to explain complex concepts like geology, chemistry, and physics, igniting curiosity in young minds. The missions also inspire the next generation of scientists and engineers. Seeing technological marvels like Ingenuity's historic flights or the MOXIE oxygen production experiment in action gives students a glimpse of what's possible through innovation and persistence. This not only bolsters scientific curiosity, but also fosters an appreciation for teamwork and long-term planning essential in planetary exploration. Curiosity and Perseverance are laying the groundwork for human missions to Mars, providing critical insights about the planet's terrain, resources, and hazards. By analyzing rocks, soil, and the atmosphere, these rovers help identify potential landing sites and regions with vital resources like water ice. This data is key for sustaining human life on Mars, enabling the creation of drinking water, breathable oxygen, and even fuel for return trips. Perseverance's MOXIE is particularly groundbreaking. By extracting oxygen from Martian carbon dioxide, MOXIE demonstrates how future habitats could produce life support essentials locally, rather than relying on costly resupply missions from Earth. Terrain mapping and imaging, made possible through tools like Perseverance's Mastcam-Z, aid planners in designing rovers, habitats, and equipment suited to the planet's unique challenges. The success of robotic missions has fueled ambitious plans for manned missions to Mars. NASA's Artemis program, focused on returning humans to the Moon by the late 2020s, is seen as a stepping stone for deep space exploration. By 2033, NASA aims to send astronauts to orbit Mars, potentially leading to surface missions later. SpaceX, driven by Elon Musk's vision of a multi-planetary species, is aggressively developing its Starship spacecraft, designed for mass transportation of humans and cargo to Mars. SpaceX's timeline is bold, targeting a potential Mars landing by the early 2030s. The collaboration between government agencies like NASA and private companies such as SpaceX could fast-track progress, combining NASA's expertise with SpaceX's rapid innovation. Mars exploration is shaping strategies for sustainable living in extreme environments. Challenges like building radiation-shielded habitats, extracting water from soil, and generating energy from renewable sources offer invaluable insights not only for Mars, but also for exploring other celestial bodies like Europa or Titan. Mars acts as a testbed for developing closed-loop systems essential for survival far from Earth. Technologies refined on the red planet, such as recycling oxygen and water or autonomously repairing infrastructure, are stepping stones for exploring the outer solar system. As we continue to unravel the mysteries of Mars, one thing is clear. The journey is just beginning. With each new discovery, we inch closer to answering the age-old question, are we alone in the universe? And with every step forward, we pave the way for humanity's future among the stars.